means recall means there are four options. There were four options. Hotspot भी दे. Eraser है. So confusion matrix, let me draw it to confusion matrix. Okay, so what does confusion matrix state? Means from confusion matrix how can you get precision and recall? So if precision is this one and recall is this one, you are getting my point. Precision is this upon total this, you are getting my point. If it is your, like first was signature. What was the first option? Automatic signature detector for monetary purposes. To open the options. Monetary purposes means what do you want? What your machine should predict? Your question was what was the question? My laptop is not. So can you show me the question? So there were you should not miss the gold mine. It can happen that gold mine is not there. No, it's not for mining. For that, we are not talking about for mining. We're just locating a gold. The locating gold mine. Okay, you're getting my point. Means what was the question? Question was that we should not miss a gold mine. Means my recall should be high. Precision can be low. Precision low means I can say that if it is not a gold mine, I am predicting it as a gold mine, it's fine. If it is not a gold mine, I am predicting it as a gold mine, it's fine. But if it is a gold mine and I am missing that one, so you are getting my point, it is not good. So my recall should be high and my precision should be, it can be compromised. Similarly for automatic detection of fatal rare disease. Fatal rare disease means if you are suppose you are suffering from some rare disease like pneumonia or cancer, your model should not miss that disease. It can happen that your model you are not suffering from disease. It can, if it is predicting you are suffering from disease, that is fine. But you are getting a point. But you are suffering from disease and your model is predicting you are not suffering from that disease. You are getting a point. I should explain. Do it more explanation regarding that. It's fine. Means what is precision? Precision is confusion matrix is like this. This is actually actual. This line is actual, and this is predicted. You getting my point? So for the first question, rare disease. For rare disease, okay. For rare disease, if my model this is actual no, actual yes, predicted no, predicted yes. So what was the first question? First question was if recall may be compromised, but precision should be, which of the following application will lead high precision even if recall may be compromised. Recall means high recall means recall means this one. You are getting my point. Recall means you are actually how many numbers of yes are there and how many you are predicting yes. And precision means how many you are predicting yes and that is actually yes. You are getting my point. So for having high precision, this should be less and this should be more. For having high recall, this should be high and this should be less. So getting my point. Everybody is clear with this or not? So for first question, responses. How many of this question directly? Signature verifier means you are getting a point. You should be precise. Signature verifier should be precise. No, signature verifier. If let me explain. Don't be confused. Let me. Your signature verifier.
It should be precise. What recall maybe low, but it should be precise.
It should be precise.
But option is not.
Wait a minute. Your signature verifier. Let two business students. The signature verifier. What your model should do means your model should not means that false signature. It should not accept it. It can happen that my signature is predicting it as false, but it should not accept any false signature. You are getting my point. So how your model will be your false signature. Just like your no, yes. If your signature is yes, means it is your signature. It should predict. It can predict. No, it can predict yes also. But if it is not your signature and it is predicting yes, whether it is fine or not. No, it is not fine. But if it is predicting over here, you are getting a point. So recall should be high and precision should be low.
So recall should be low, right?
No, you are not getting a point. It can happen that it is your signature and it is predicting not your signature. So you are getting a point.
So precision should be low, right?
No, precision. If it is your signature and your model is predicting not your signature, that is fine. If it is your signature, means your signature, and your model is predicting it's not your signature, it is fine. But if it is not your signature, you are getting a point. If it is not your signature and your model is predicting yes, and this one, it is not fine. So precision should be high. Yes, that is the answer. You should check it. That should be the answer. Precision should be high. Yes, automatic high signature. You're getting a point. You're right. So if it is not your signature and your model is predicting yes, that is your signature. So that should not be the case. Means in banks, what happens? If somebody comes that is not your signature and sign in the checkbook, your model should not predict that it is the correct checkbook. But if you sometimes your signature and it's predicting that it's not your signature, that is fine. But if somebody else is coming and signing like you and saying that the model is predicting, yeah, it's fine. It's not good. If you are signing and the model is saying that it is not your signature, that can happen. So you're getting my point. If it is actually your signature and model is predicting no, that is fine. But if it is actually not your signature and the model is predicting yes, that should not be the case. You are getting my point. So this should not be the case. So this should be less and this should be high. So if this should be less and this should be high, so it should have high precision. Okay, you are getting my point. So, but rest of the cases, what for the rest of the cases means for gold mine detection, for fatality, for rare disease detection, which that for that case and for the rest is automatic security scanner. Security scanner, we don't want any hazardous material to pass through. You are getting a point. We don't want anything. Means if it actually is hazardous material, if it is actually a rare disease, we don't want to miss that. We don't want to miss that. If it is actually yes, our machine should not be saying that no. If it is no and your model is predicting yes, that is fine. We are getting a point. If your model is no and predicting yes, then the precision can be compromised. But if your actually model is yes and your model is predicting no, that should not be the case. We are getting a point. So if your model is yes, so we should have less number of points over here. So for the rest of the three options, we should have high recall and less precision can be. So low precision can be compromised. You are getting a point. Everybody is with me or not? So next 6 questions are very easy.
मेरे पास है
I should discuss this or not, everybody? Should I discuss? Or I should move forward? Should I discuss? How many of you want? Sorry? You only want?
Sir.
You want? Okay. What was the question? Confusion matrix 2016, 2015. These are actually. It is asking what is the precision of detecting class marigold? Precision of detecting class marigold 5, 15 and 30. Okay. What is the precision? 30, 30 is your, actually it is predicting 30. Total 45 it is predicting, but out of that 30 is correcting. So what is the precision? 30 by 45, that is the answer. Okay. Next question. 6 by 9, huh? What is the precision of detecting the class? Rows. Similarly, you can get that. So for precision of detecting rows, how many rows it is predicting? 25 rows it is predicting. And out of that, how many are correct? 20 are correct. So 20 divided by 25. Then, what is the recall of detecting class marigold? So shortcut technique to find recall and precision is, for recall you go like this, and for precision you go move like this. So what is asking? Recall for class marigold. Recall for class marigold will be class marigold is this. Okay. So out of 35 marigolds, how many is predicting marigold? 30. So 30 divided by 35. So 30 divided by 35. You are getting a point. So next question. Next question was first 3 cross 3 confusion matrix. What is the precision? For that I have to draw the confusion matrix. So please be with me. So please correct me if I am wrong anywhere. I may draw the wrong confusion matrix. Should I do this or not? How many of you want? Or I should skip? Do you want? Or you can try it yourself. It's very simple. Just like, should I do? Okay. So, see, my automatic recognizer gave the level as, so this is the predicted value. So this one is my model predicting, and these are my actual values. So how many actual rows are there? 1, 2, 3, 4, 5, 7, and how many it is predicting out of that? 1, 2, 3. So I should draw my confusion matrix. Let me draw. Okay. So how many are there actually? There are 7 marigolds. Out of that it is predicting 3. So 3 and rest. How many marigolds? So 3. Sorry. 3 lily. And how many? Marigold? 2. Okay. So for this one? 3. 1. 2. So what is the first question? What is the precision of detecting roses? What is the precision of detecting roses? For precision I told vertical, you should go vertical like this. Okay, for precision you should see. How many total? It is predicting roses. 3 plus 2 plus 3. How many? 5 plus 3, 8. So out of 8, how many are actually roses? 3. So 3 by 8. So 3 by 8 means 0.375. The next, what is the recall of detecting marigolds? Recall of detecting marigolds means you should go like. So how many marigolds are actually there? 4 plus 3, 7. So how many it is predicting, right? So 2 by 7. So then, what is the accuracy of detector? What is the accuracy of detector? So accuracy of detector, how can I find that? What is the accuracy of detector? So total means I should add the trace element. You are getting my point? And divided by total. Everybody is getting or not? Okay, so add the total element. 3 plus 2 plus 2. 4 plus 3, 7 divided by 20. You are getting my point? So it's 3.5 divided by 10. So 0.35. Okay. So everybody is clear? So now assignment. So assignment 3, should we discuss or not? Okay. Neural networks.
नहीं, assignment 3 का gradient वाला जो part है वो समझा था। मैं समझा रहा।
ठीक है।
इसमें चल रहा है ना?
हाँ, अब देखिए तब तक मैं कुछ कर। So here Keshav will be discussing assignment 3. So how many of you are now getting some idea of neural networks? What is neural networks? How many of you are not getting anything from neural? Have no idea what we are actually discussing about neural networks. What is neural networks? Why are you studying such mathematics? So everybody is clear. So if I call any one of you to the blackboard, so I'll give a short question. So you can solve. Yes. So please be clear. You are not. Okay. Please raise your hand. I'll explain in 5 minutes. Do you want or not? I should skip. Do you want? How many of you want? Okay. So neural networks. If you are clear with neural networks, then your whole machine learning is you are getting my point. For whole machine learning, you will be updating your weights. For whole machine learning, you will have some formula for updating the weight, and you will put that updating formula inside the loop. That is whole machine learning. आप बताएंगे क्या न्यूरल नेटवर्क्स?
बताइए, थोड़ा सा स्टार्ट
बताइए,
करके बताओ।
हाँ कैसे?
न्यूरॉन से बताइए, लेयर्स MLN।
ओके,
आप
आप कराइए। आप तो सिनेप्टिक वेव्स अच्छे से जानते हैं, बता सकते हैं।
स्टार्ट करिए ना।
Okay, so neural networks. So in neural networks, so do you want me to discuss neural networks first or assignment first? Neural networks. Okay. So neural networks. So there is something called input layer. There is something called hidden layer. There is something called output layer. You are getting my points. So we don't have any idea of how many number of hidden layers we should take. I'll just not go very deep into neural networks. I'll just cover neural networks. I am assuming that everybody of you have watched the video or not? How many of you are there who has not watched single video on neural networks? You watch videos? Okay. So I am assuming that you have some little idea of neural networks. What are neurons? So there are 3 things: input layers, hidden layers, and output layers. So how many hidden layers I should take, and if only one hidden layer, how number of elements I should take? So that I should not decide. That I should give heuristically. Means I should give heuristically such that my error is converging. Means my computation should be very low to get that error converging. So my computer should run for less number of loops. You are getting my point. So first of all, what is neural network? So neural network, if your data, for example, iris data, how many of you watched that video of iris data? So iris data, what are the input elements? Sepal length, sepal width, petal length, petal width, and what are the output? 3 flowers: setosa, versicolor और virginica. ठीक है, जो भी है 3 वो ऐसे वो that 3 flowers are just hypothetical. We can say that lily, marigold और rose. Okay, so based upon sepal length and sepal width, petal length and petal width.
उस साइड जहाँ पे कनेक्शन होता है लेफ्ट साइड।
ठीक है, यही खड़ा हो जाऊँ क्या?
हाँ, यही से।
ओके। So I have actually, what are datas? I have my datas with me, and I want my model to predict that whether, based upon some input data, I want that my model to predict whether it is lily, whether it is marigold, or whether it is rose. You are getting my point? Now, you can also say that I have some datas, just like what I have: sepal length, sepal width, petal length, and petal width. Okay. So I have in that data set, how many number of samples are taken? Any one of you have gone through the samples? What are samples? How many number of samples data are there? You are getting my point. What are samples? How many samples are there? 150 samples are there. So 150 samples, 50 from each data set. So based upon that, I should build a neural network model that should predict whether that flower is lily. What was 3 flowers? You are okay. Let it be anything. Okay. So I will assume that 3 flowers were lily, marigold, and rose. Okay. So based upon these 4, I have already given some data set, output y, as a form of 0, either 0, 1 or 2. So I have given 3. So my output is 0, 1, 2. So let me discuss about input. So inputs are given in terms of centimeter or something. You are getting my point. So sepal lengths are given. So now what I will do, I will take this all 150, out of 150, I will split my data to 120 and 30. And based upon that data, I will build a model. So what my neural networks will do now? My neural network it has 3 things: input layers. So here input layers, how many number of input layers will be there? How many elements in input layers? How many neurons? 4. But if I am taking one bias, you are getting my point. Bias should be taken or not? So input layers have 4 elements. Plus I am taking one bias. So I can have any number of, let's assume it is having 5 elements in first hidden layer. And output, how many number of neurons in hidden layer? Output layer? 1. So my output is 1, but how I am taking 3? Because I will one hot encode. So I should have 3 outputs. So you are getting my point. So if I give you any other data set, just like MNIST data set, can you build your model? Can you take how many number of inputs will be there, how many hidden inputs, how many hidden layers, how many neurons in hidden layers should be there, and how many output neurons should be there? So you are getting my point. So I have 3. So what my neural networks do? Neural network is simply one model that for each element it will be having 4 or 5 weights. So 5 for this, 5 for this, 5 for this, 5 for this, and 5 for this. You are getting my point? So 5 weights for each neurons in the input layer. So 5 into 1, 2, 3, 4, 5. So 25 number of weights will be there. And here also similarly. So for each element in the hidden layer, how many number of weights will be there? 3. So 3 into 1, 2, 3, 4, 5. So 5 into 15. So 15 weights will be there. So what my neural network is doing actually, so it will actually multiply this weight. Okay. For getting the output over here, first of all my input will be, suppose I'm taking one sample data. Initially it will be having some 1.0. Let's suppose that its input is 1.0, 2.0, 3.0, and 1.5. So my model will be taking 1.0 here input, 2.0 here, 3.0, and 1.5, and my bias is 1. So this data will be multiplied with the weights, respective weights. You are getting my point. So after multiplication of weight over here, so that I call H. You are getting my point. So this is H1, this is H2, this is H3. What is H? H is equal to respective weights multiplied with the element. So this weight will multiply with this element, this weight will multiply with this element. So respective elements weights will be multiplied with the respective elements. So after that I will get some, so it means summation, H1 will be summation W I1 I0 into X I0. So I0 varies from 1 to 5. You're getting my point. So h1 will be like that. So I'll get some h1 over here. Everybody is with me or not? So I'll multiply simply my weights over the input. So I'll go on multiplying these weights. I'll get some h over here. So after getting h over here, similarly I can go get also h2. For h2, what I'll do? This will be actually w1. So summation I0 onto 5 w2 I0. That is from x I0. You are getting my point. So there will be also 5 weights over here. So it will multiply with the input and we'll get some h2 over here. Similarly h3 over here, h4, h5 over here. So everybody is with me or not? So after getting the h1s, then what I will do? I'll activate it. Activate means I can have 3 type of activation. You are getting my point. But we can use, so I am using sigmoid activation. What is sigmoid activation? The h that I am getting, I will sigmoidally activate it. Means I will take that value 1 plus e to the power minus h. So I'll get some v over here. So it will be v1, so v2. So everybody is with me or not? So v1, v2, v3, v4, v5. So after that, similarly I will multiply weights over here. I'll get some capital H. Let me assume that is capital H. H1, H2 or H3. Everybody is with me or not? How will get h1? H1 I will multiply these weights with v1, v2, v3, v5. So everybody is with me or not? So after that, I will sigmoidally activate that and I will get some output y1, y2, y3. So when I take this 1.0, 2.0, 3.0, 1.51, so its actual output is 0. You are getting my point? So its actual output is 0. But if I multiply initially I will randomly initialize my weights. You are getting my point? I will give some random values. Let it be 0, it can be 0.01, it can be 0.5. So actually initially we take our values from -1 to 1. You can have your you can take initially assume your all weights to be 0 also. You can assume that also. You can take any values from -1 to 1. Okay, so for randomly I will initialize that and I will multiply it with my input data. So I will get some h1. Similarly I will get v1. After that I will get some output over here. My output actually when I will see that my output is not matching with 1 0 0. So what I will do? I will find the error. After finding the error, what I will do? I will back propagate that. What is that back propagation? You are getting, everybody is with me or not? Back propagation means w is equal to w new is equal to w old minus eta del e by del w. Actually what is my error? That is error function. Error function is defined by half of yd minus y whole square. So my error is a function of y and my y is a function of w. That is why I can differentiate e with respect to w. So you please go through the videos and will check chain rule. So after that you will get some this weight as a function of w is equal to 9 minus del e by del w. Everybody is with me or not? So after that I will get update some for individual weights. I will be having some weight update rule. So I will update my weight. So after that after I updated my weight, I will go for the next sample. I will move forward. I will get some error. Then again I will back propagate and update my weight. Okay. After updating the weight, I will again take next sample and update the weight. So after that I will take it for 120 samples because I have taken 120 training data sets. So I will go, that is called one epoch. So after that I will move again. So I will check that whether my model is having error or not. If my model error is very less, after I take some input data set and I found the output and match with the desired output. If my error is very negligible, I'll stop over there. You are getting my point. If my error is not very negligible, what I'll do? I'll again update my weight and go on updating the weight. So after there will be time when my weights will be converging, means my error will be very negligible. So that will be my final weight. So that is the fundamental concept of neural networks. So everybody is clear or not? So please go through the video. So now people sir will be explaining. We start machine learning on. Okay.
स्कूल चले